In this video, we'll solve numericals which are based on Ohm's law and resistivity. Page number 112, example 12.3. Question number A. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? Question B. How much current will an electric heater coil draw from 220 volt source if the resistance of the heater coil is 100 ohm? First, what they given, we'll need to write all the data. What they are asking, how much current will an electric bulb draw? How much current? That is I equal to question mark. Draw from a 220 volt source. Voltage they given, how much? 220 volt. If the resistance of the bulb filament is 1200 ohm, how much resistance? R equal to 1200 ohm. Okay. By Ohm's law, we know that V is equal to IR. Okay. So this implies I is equal to V by R. What is the value of V? 220. Then divided by 1200. To divide this, finally, we are getting 0.18 ampere. So A part is over. The bulb draw how much current? 0.18 ampere current. Now the second part of the question. In the second part, they are asking how much current will an electric heater coil draw from a 220 volt source. How much current will draw? I equal to question mark. Okay. Then voltage they given how much? 220 volt. Resistance of the heater coil how much? 100 ohm. So again by Ohm's law, V is equal to IR. So this implies I is equal to V by R. What is the value of V? 220 divided by R value 100. Divide this, you will get 2.2 ampere. What it means? The heater coil draw how much current? 2.2 ampere by the electric source 220 volt, showing the heater coil having resistance 100 ohm. For that they draw how much current? 2.2 ampere. Next question, question number 12.4. 12.4. Okay. The potential difference between the terminals of an electric heater is 60 volt. How much voltage? 60 volt. Okay. When it draws a current of 4 ampere. What is the current? 4 ampere of current is drawn by a heater. Okay. What they are asking, what current will the heater draw if the potential difference is increased to 1 volt? Suppose for 120 volt, when we change the voltage from 60 to 120, what will be the current? They are asking. I equal to question mark. In this case, first we will find the resistance of the heater. Okay. Since in the second case, same heater we are using, means resistance will be the same in the second case. This is a case 1. This is case 2. Okay. Okay. From case 1, first we'll find resistance. Okay. How we'll find the resistance? By Ohm's law. V is equal to I into R. So this implies R equal to V by I. What is the value of V? 60. Okay. 60. What is the value of I? 4 ampere. So we are getting what? 15 ohm. The electric heater showing how much resistance? 15 ohm. By taking this resistance, we can find the current in that circuit by changing the voltage from 60 to 120. Now we have the data. In the case 2, what data we have? Resistance we know 15 ohm. Same heater. In the second case also, voltage changed here from 60 to 120 volt. Current we need to find. Again by Ohm's law, V is equal to IR. This implies I is equal to V by R. What is the value of V? 120. What is the value of R? 15. Divide this, what you will get? 8 ampere. Okay? Means for 120 volt, the current in the current here drawn by the heater is how much? 8 ampere. Observe here, for 60 volt 4 ampere current will draw. For 120 volt how much? 8 ampere. Means when you double the voltage, current also double in the circuit. Next example is example 12.5. Question is, resistance of a metal wire of length 1 meter is 26 ohm. What they given? Length of the metal wire. How much? 1 meter. And resistance how much? 26 ohm. 26 ohm at temperature 20 degrees centigrade. If the diameter of the wire, they given 0.3 millimeter. Okay? What will be the resistivity? Rho they are asking. Resistivity. Okay? Of the material using table part predict. We need to predict what value you are getting, whether that value is matching with the this chart. Okay? Let us say here. We know the resistivity formula. Rho equal to resistance into area divided by length. Okay? Here observe this formula and these values. They given R here, they given length here, but they not given area value. Okay? Cross section area in the sense this area. Okay? This cross section area. How to find this cross section area? It is nothing but a circle. They given what? A diameter. Okay? What diameter they given? In millimeter, 0.3 millimeter. Okay? So diameter is equal to what? Radius equal to diameter by 2. Okay? So what will be the radius we'll get here? Diameter is how much? 0.3 divided by 2. So this gives you what? 0.15 millimeter radius. By using this value, we can find the area. We know this area of a circle. Area of a circle is equal to pi r square. What is the value of pi? 3.14. What is the value of r? 0.15 square. But observe here, this value r we got here 0.3. It is in millimeter. We need to convert this 0.3 millimeter into meter because we need SI unit. Since ohm is SI unit, length is meter, that is also SI unit. So we need to convert in SI unit. Convert this 0.3 millimeter into meter. So we will get here 0.3 into 10 to the power minus 3 meter. Okay? That's why area, this R value I am taking here 0.15 into 10 to the power minus 3 whole square. This is the radius value in meter. Now, so this when we simplify, we will get 0.15 into 0.15 into 10 to the power 2 3 is 6 minus 6. Okay? This is A value. Now put the A value, this A value in this equation. Okay? We know R value, we know A value here, we know the length. Okay? By putting all the values in the resistivity formula, R value they given 26 ohm. A value we just found here, how much? 3.14 into 0.15 into 0.15 into 10 to the power minus 6 divided by length. How much the length? Length is there, no? How much? 1 meter. Okay? 1. Okay? Now multiply all these values. Finally we'll get 1.84 ohm meter. This is the required answer. In this example 12.6, a wire of a given material having a length L and area of a cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having a length L by 2 and area of a cross section 2A? Okay, what they given? A wire, say length L they given and cross section area of the wire, say they given how much, A they given, and the resistance they given 4 ohm. Okay. Okay, in the second case what they're asking, suppose the length is from the L to L by 2, half the length of the previous one, and cross section area is double the cross section area of the previous one. What will be the resistance they are asking? Okay. Okay, and what material they are using? In the second case, same material, length is a half, area is a double. What will be the resistance of the conductor showing? And same material means rho is the same, rho 1 equal to rho 2 equal to rho. Resistivity will be the same. We know the formula of resistivity, rho equal to Ra by L. Suppose it is rho 1, this is R1, A1, L1. Okay. Suppose it is rho 2, then we have R2, A2 and L2. Put all the values in this formulas. Rho 1 in the sense rho here, R1, how much, 4 ohm they given, A1, how much, A they given, L1, L they given in the first case. In the second case, rho 2 in the sense rho, R2, want to find A2, 2 into area, cross section area, and L2 how much, L by 2. Okay. Left side are same, means right side also same. So 4A divided by L is equal to R2 into 2A whole divided by L by 2. Okay. Now we need to find this R2. So R2 here into 2A, change the sign into multiplication, that is become 2 by L. This is 4 by L. Okay. Take all the values, this value to this side. We'll get what, R2. Okay. So here 4A by L. When 2A comes this side, it will comes under division. When 2 comes this side, it will comes under division. When L comes this side, this in denominator comes here, numerator L will be here. Now this L get cancelled. 2 and 2, this 2 to the 4, this 4 cancel, A cancel. What is the remaining? 1 is the remaining. Okay. So after changing the length into half and cross section into double, the resistance of the conductor of the same metal showing how much ohm? 1 ohm. That is the required answer.